Good morning, everyone, and welcome. Today, we're going to tackle a concept that is, I believe, absolutely foundational for anyone serious about business analytics: matrix multiplication. Now, I know what some of you might be thinking when you see the word matrix, maybe some abstract, complicated math. I want you to push that thought aside. For our purposes, for a future business leader, a matrix isn't just some grid of numbers. It's a model. It's a powerful way to represent a piece of your business reality, whether that's sales data, supply chain logistics, or financial forecasting. Getting a firm grip on this tool isn't just helpful, it's essential.
So let's start by framing the problem you'll all be facing. A modern business is just a swirling vortex of numbers, a constant stream of data. And we're not just talking about the top-line sales figures. Think about it for a second. You've got inventory levels, shipping costs, customer acquisition costs, employee hours, marketing spend. The list goes on and on. The biggest challenge you'll face as a manager in the 21st century isn't a lack of data, it's having way too much of it. Our job, starting today, is to learn how to bring some order to that chaos.
And this right here, this is what that chaos often looks like. This is the kind of raw data dump that could land in your inbox on any given Monday morning. You've got sales, you've got inventory, you've got costs, spread across different regions and products. Now, could you make a decision based on this? Maybe. You could squint at it and say, looks like product X is doing pretty well out west. But folks, that's not analysis, that's a guess. What you can't see here, not easily anyway, is the connection between all these numbers. What's the total revenue for the entire North region? What's the total cost of goods sold for just product Y? Trying to answer these critical questions from a messy table like this is slow, and honestly, it's just asking for mistakes.
And this is exactly where matrices come in. They are the tool we use to find the signal in all that noise. We take that disorganized raw data and we give it a structure. A matrix, by its very definition, forces us to be disciplined. We have to organize our numbers into rows and columns, and that simple act of organization is what unlocks its power. It allows us to perform massive, simultaneous calculations that would be a nightmare to do otherwise. The goal here is simple: to move from being overwhelmed by data to being empowered by clear strategic insights.
Okay, so let's dive into the mechanics. Before we can use this for any fancy business strategy, we have to be absolutely perfect with the calculation itself. And the most important part, the very first thing you always have to check, isn't even about multiplying. It's about compatibility.
I want everyone to really focus on this slide. This is the golden rule. It's non-negotiable. Let's break it down. When you have two matrices, let's call them A and B, we describe their size by their dimensions, rows by columns. So if matrix A is an M by N matrix, it has M rows and N columns. The rule says you can only multiply A times B if the number of columns in A, that's N, is the exact same as the number of rows in B. We call these the inner dimensions. If they don't match, you just can't do it. The operation is undefined. But if they do match, the new matrix you create will have the outer dimensions, M rows from A and Q columns from B. This isn't some arbitrary math rule. We're going to see that it's what makes the business logic work perfectly.
To make sure we get this right every single time, we're going to follow a very strict four-step process. Step 1, you just heard it, check the dimensions, always. Step 2 is where we start the action. You pick one row from the first matrix and one column from the second. Think of it like you're lining up the two pieces of information you want to combine. Step 3 is the real heart of the operation, what's called the dot product. You multiply the first number in the row by the first number in the column, the second by the second, and so on, and then you add all those little products together to get one single number. Finally, step 4. You take that new number and place it in the correct spot in your answer matrix. Then you just repeat, repeat, repeat until the whole thing is filled out.
All right, let's make this real with a simple example. We've got matrix A and matrix B here. Both are 2 by 2 matrices. So step 1, check the dimensions. Matrix A has 2 columns, matrix B has 2 rows. Do the inner dimensions match? Yes, 2 equals 2. We're good to go. We can also predict the size of our answer. It's going to have the outer dimensions, 2 rows from A and 2 columns from B. So we know we're building another 2 by 2 matrix.
Now this slide shows you that core calculation in action. We want to find the number that goes in the very first spot, top row, first column of our new matrix. To do that, we need the first row of A and the first column of B. Look at how it works. We take the first element from the row, which is 1, and multiply it by the first element from the column, which is 5. Then we take the second element from the row, 2, and multiply it by the second element from the column, 7. Now we just add those two results together. 1 times 5 is 5. 2 times 7 is 14, 5 plus 14 gives us 19, and that number, 19, becomes the very first entry in our new matrix.
And then we just keep that pattern going.
Let's do one more together just to make sure it sticks. How do we get the number in the first row, second column? Well, we use the first row of A, that's 1, 2, and this time we use the second column of B, that's 6, 8. So the math is 1 times 6 plus 2 times 8. That's 6 plus 16, which gives us 22. So 22 goes in that spot. If you follow that exact same logic for the other two positions, you get 43 and 50. And there it is, our final product matrix, AB.
Okay, so we've nailed down the how. We know the steps. But in this course, that's never enough. The real question, the one that matters for your careers, is why. How does this abstract calculation actually give us some kind of managerial insight? To answer that, we're going to take those same matrices we just used and map them onto a real-world business problem. We're moving from just numbers to revenue and cost. So let's give matrix A a job. From now on, it's not just numbers. It's our units sold matrix. Look at how it's structured. The rows represent our two stores, Store 1 and Store 2, and the columns represent our two products, Product X and Product Y. So that number 1 in the top left, that means Store 1 sold 1 unit of Product X. The 2 next to it, 2 units of Product Y sold at Store 1. See? Every number now has a specific real-world meaning. Okay, now for matrix B. This is going to be our financials matrix. Now pay very close attention to the setup here. For this whole thing to make any logical sense, the rows of this second matrix must line up with the columns of the first one. Remember how the columns of matrix A were our products? Well, that means the rows of matrix B also have to be our products, Product X and Product Y. This is the business logic that perfectly mirrors that mathematical rule about matching inner dimensions. Now, the columns here are financial data, sale price, and unit cost. So we can see Product X sells for $5 and costs $6 to make.
And this brings us right to the kind of problem a manager faces every day. You've got two different reports on your desk. One tells you how many units each store sold, the other tells you the price and cost for each product. The big question is, how do you combine these to figure out the total revenue and total cost for each store? Well, multiplying matrix A by matrix B is precisely the operation designed to answer that question, quickly and accurately.
And here we have it, the result. This isn't just a matrix of numbers anymore. It's a store performance report. Let's look at that 19 in the top left corner again. What is it now? It's the total revenue for Store 1. And where did it come from? It came from multiplying Store 1 sales by the product prices. Specifically, 1 unit of Product X times its $5 price, plus 2 units of Product Y times its $7 price. That's $5 plus $14, giving us a total revenue of $19. In one single, elegant calculation, we've turned scattered data into a clear, actionable dashboard.
So now that you've seen how powerful this is, it's absolutely crucial that we understand the formal rules of the road. Think of it like a user manual. This is a powerful tool, and if you don't follow the rules, you can get some seriously wrong answers, which can lead to some really bad business decisions. Now the good news is, some of the rules are familiar from regular algebra. Matrix multiplication is associative. That just means if you're multiplying three matrices, the order in which you group them doesn't matter. It's also distributive. But, and I can't stress this enough, there is one huge fundamental property from the math you've always known that gets thrown right out the window here. And this is where most students get tripped up.
That property is commutativity. In general, matrix multiplication is not commutative. With regular numbers, you know that 5 times 3 is the exact same as 3 times 5. The order doesn't matter one bit. With matrices, it's a completely different story. The product of A times B is almost never the same as B times A. In fact, a lot of the time you might be able to calculate AB, but BA isn't even possible because the dimensions won't match. When it comes to matrices, order is everything.
Let's go back to our business example to see why this is so important. The product AB gave us that beautiful, meaningful performance report. But what if we tried to calculate BA? We'd be trying to multiply the financials matrix by the units sold matrix. Now in this case, because they're both 2 by 2, the math would actually work. You could get an answer, but the result would be complete nonsense from a business perspective. You'd be multiplying rows of dollars by columns of stores. What does that even mean? The order isn't just a math rule. It's dictated by the business logic you're trying to model.
All right, for our final section, let's zoom out a bit. Let's stop thinking about this as just a calculation and start seeing it as a high-level strategic tool. We want to understand how this technique really enables top-tier business analysis and smart decision-making. When you put your information into matrices that represent different parts of your business, what you're really doing is building a quantitative model of how your company works. This is a really big idea.
Think about a supply chain. You could have one matrix for the raw materials needed for each product, and another for the cost of those materials from different suppliers. Multiplying them could give you a total cost of production. This approach lets you analyze incredibly complex systems in a very systematic and scalable way.
The result of just one well-designed matrix multiplication can be an incredibly powerful snapshot of your business. Let's look back at our performance report. We can see instantly that even though Store 2 brought in more revenue, $43, its costs were way higher at $50. Now, this single matrix doesn't give us all the answers, but it tells us exactly where to start looking. It forces us to ask the right strategic questions. Is Store 2's product mix less profitable? Are their shipping costs higher? This is what data-driven management is all about, using numbers to ask smarter questions.
So, to wrap up, let's quickly review the big ideas from today. First and foremost, order matters. The fact that matrix multiplication is not commutative is a critical concept you have to remember. Second, matrices are your best friend for organizing complex, messy business data. Third, the whole point of doing the multiplication is to create new insights that you can actually act on. And finally, because this is a structured process, you can rely on it for consistent, repeatable analysis.
So I'll leave you with one final thought to take with you. Today, we modeled a very simple business with just 2 stores and 2 products. I want you to start thinking bigger. How could you use the same idea to model the profitability of different customer groups based on what they buy and how much it costs you to acquire them? Or how about modeling a portfolio of projects based on their resource needs and their expected returns? The mathematical tool is exactly the same. Its strategic power is only limited by your ability to see the underlying structure of your business. This is the bedrock of so much of modern business analysis.